Today I'll be talking about the physics of trampolines. I hope you enjoy and learn something along the way. Trampolines date back to 1934 when they were first developed and were originally used to train astronauts and were used as a training tool for other sports. They soon became popular in their own right and a sport was born. The first modern trampoline was built by George Neeson and Larry Griswold around 1934 at the University of Iowa. It was initially used to train tumblers and astronauts and as a training tool to develop and hone acrobatic skills for other sports such as diving, gymnastics, and freestyle skiing. People enjoyed the sensation so much they began to trampoline just for the fun of it, and it became popular all by itself. Trampolining made its first appearance at the 2000 Games in Sydney, with men's and women's competitions. The number of events equals 2 has remained unchanged since then. Even though trampolining seems very simple, there are quite a few physics aspects behind it. The first physics aspect is kinetic energy. Kinetic energy is created when an object with some amount of mass is moving with a given velocity. In other words, all moving objects have kinetic energy. The formula for kinetic energy is as follows: Ke equals 1/2 multiplied by mv squared, where m is mass and v is velocity. When you jump on a trampoline, your body has kinetic energy that changes over time. As you jump up and down, your kinetic energy increases and decreases with your velocity. Your kinetic energy is greatest just before you hit the trampoline, as you can see on position 1 of the picture, and when you leave the trampoline surface on the way up, as you can see on the position 2 of the picture. Your kinetic energy is 0 when you reach the maximum height of your jump, as you can see in position 3 of the picture, and you begin to descend. Potential energy changes along with kinetic energy. At any time, your total energy is equal to your potential energy plus your kinetic energy. Potential energy is a function of height, and the equation is as follows: Pe equals m multiplied by g multiplied by h, where m is mass, g is the gravity constant, and h is the height. The higher you are, the more potential energy you have. As you leave the trampoline and you begin traveling upward, your kinetic energy decreases the higher up you go. In other words, you start to slow down. And as you start to slow down and gain height, your kinetic energy is transferred into potential energy. And also vice versa, as you fall, your height decreases, which decreases your potential energy. This energy decrease exists because your energy is changing from potential energy into kinetic. The final aspect of physics involving trampolines is Hooke's law, which deals with springs and equilibrium. As you land on a trampoline, the springs and the trampoline surface stretches as a result of the force of your body landing on it. Hooke's law states that the springs will work to return to equilibrium. In other words, the springs will pull back against the weight of your body as you land. Hooke's law is stated in the following equation: F equals negative k multiplied by x, where F is the force, k is the spring constant, and x is the displacement of the spring. As you can see, as I am jumping up and down on the trampoline springs work to return to equilibrium. Thank you for watching my video. I hope you enjoyed it.